We're going to continue with this Excel spreadsheet and look at sensitivity and specificity. So we're looking for a device. This is usually used for a lab test or a diagnostic test or something like that. And when you have the truth up here of the true existence of the disease, in this case we're going to say the truth is that we know the person is myopic. We have done the tests, looked at refractive error, and we've concluded that there were 600 children who are myopic and 2,948 who are not. And our test is to ask the child or the child's parent, do you spend more than 35% of your free time outside? So if you're not in school and you're looking at studying and other stuff, or in the summertime, do you spend more than 35% outside? So this is our screener, spending more than 35% of your time outside or not. And then how do we do? Well, we get this matrix, same matrix we had before, and we look at sensitivity up here. We get it's 14% sensitive. In other words, if you get this answer correct, or if not correct, but if you say you go over 35% of the time, and we know that you have myopia, then 82 divided by 600 is 0.137. Specificity is the formula when you say you don't spend it outside, and then you're truly not myopic, then the 2212 divided by 2948 is specificity, and in this case, this test is 75% specific. Now that's all well and good, and when you're getting your test approved by the FDA, you'll do a study something like that, in which you look at 100 myopes and 100 non-myopes and see how you do on your screening test, and you'll come up with sensitivity and specificity. But as a clinician, you don't really care about sensitivity and specificity nearly as much as you care about positive and predictive value. Because when you have a patient in your chair, then you don't know that they have myopia. Or let's say in this particular case, you would do something else. But in any time you're doing some sort of a screening, you don't know if you're gonna just determine if the person is myopic or not by asking if they spend time outdoors. You want to know what is the probability, if they are outside, what is the probability that they are actually myopic? If they say yes here, then what's the probability that they are truly myopic? And that's positive predictive value, and it is this cell divided by the total. This is a very different concept from sensitivity. So sensitivity is saying, given that I know the person has myopia, what's the probability that my test is positive? Positive predictive value is, given that I know my answer to the question is yes, what's the probability that I have myopia? That goes this way. So sensitivity is about 14%, positive predictive value is 10. Specificity and negative predictive value have the same relationship. If the person in your chair says no, you want to know what is the probability that they actually don't have myopia. And so that's negative predictive value. It's those two variables. Specificity is you know the person doesn't have myopia. What is the probability that that the test says that they don't, in this case being inside. So it's important to do positive and predictive value. Now, this calculation right here has been made under the assumption that this was not a case control study. And in fact, it wasn't really. It was a longitudinal study. I don't know that the population would still be considered a random sample, but for our purposes, we're going to say these numbers were okay. So it's okay to calculate in this direction on positive and negative predictive value. But if we did have the example where we had 100 myopes and 100 non-myopes and we calculated it, then we can't go in this direction because we've artificially manipulated the numbers. We have to put into consideration the prevalence, which in this case is 0.19. And now we calculate through using Bayes' theorem the probability that it's a positive predictive value. And in this equation, we use sensitivity, specificity, and prevalence in this formula in order to get positive predictive value. The same way with negative, we use the sensitivity and specificity in a little bit different ways with the prevalence. So our actual positive predictive value was 11% instead of 10. Our negative predictive value was 92 instead of 81. So prevalence matters if the in the case where we don't know the actual prevalence of the data. So that's pretty much sensitivity and specificity. The things that you want to remember is that as a clinician, you care much more about positive and negative predictive value because you want to know the probability of being right when you use the test for a patient in your chair. When you're developing a test, you're more interested in sensitivity and specificity because you don't want to guess at prevalence and have that be impacting on the outcome. You want to know exactly what those values are, and without this third subjective prevalence measure going into it. So you want to calculate those. So it depends on your perspective as to which of these measures you're interested in. Generally speaking, studies give you sensitivity and specificity, and you have to calculate positive and negative predictive value. And that's why you have this spreadsheet here. You can now do that.